Hello, so we're going to review for the final exam, and this is the first part. And the first part includes Chapter 5. So the first part is really Math 110 only if you're a Math 112 student, but it doesn't hurt to see the review over this either. That doesn't hurt anything. Okay, so it says simplify the expression. Assume that all bases are not equal to 0. This just means that if n were a 0, you would have a 0 in the bottom, and that's not legal, you know, because that's at undefined. So that's all that means. So don't worry about that. So you're going to simplify. And the rule is a over b to the n is a to the n over b to the n, or it just means that everything inside gets that outside exponent. Sometimes you can simplify inside, and that's okay. But in this case, oh, well, you could. You see what I'm saying here? Like, I had to look at this. Some students immediately take all these pieces and take them to the 6th power, and you have to realize you could actually simplify the inside first, and that makes your numbers a little more manageable. So it's completely okay with me if you wanted to make big numbers, but 3 to the 6 and 6 to the 6, that's huge. But what if I said, hey, I'm going to simplify the inside? So there are different ways to do these. 3 over 6 is 1 over 2. You see what I'm saying? So there's a 2 inside. That doesn't change the variables. And then we still have the 6th power on the outside. So you could take 3 to the 6 over 6 to the 6 and then simplify it, or you can simplify it inside, which is better, because then you don't have huge numbers to deal with. And then you use that power rule within this. This is one of the power rules. It's a quotient to power. And also you have to realize you have a product to power rule, which is that a b to the n is a to the n, b to the n. And that just means when you're multiplying, each one of these gets outside exponent. So that applies here to the bottom. So m to the 5th to the 6th. This is why I say it's Easter, and this bunny, these bunnies want to multiply. You know, power to power, you multiply. So power to power, you multiply. So you say, well, what's upstairs? M to the 30th, because that 6 wants to multiply with the 5. But these are busy bunnies, and they want to multiply. That one wants to multiply with all of them. And this is a 2 to the 1st. So the 6 multiplies with that 1, and then the 6 also multiplies with that 2. So we have a 2 to the 6, n to the 2 times 6 is 12. And you have to realize that 2 had an exponent of 1, and those are really the things that are multiplying those exponents. So then you simplify and say that's m to the 30th over 2 to the 6, 2 to the 5th is 32, so that's a 64. The computer's gonna want 64. And that's all you can do. Hold on. Yes? So if you had a calculator and you did, you took this power of 6 and distributed through first, then you would have 3 to the 1st, 6 to the 1st, and then you'd have 3 to the 6 over 6 to the 6. Those are huge numbers. So, but you can do it certainly, and the calculator's going to end up with 1 over 64 in the end. See, so it'll do that for you. Okay, so how are we done? Cake so far? Yeah. Let's clear. And then, so we'll see how far we get today, and then we'll do this again if you guys want tomorrow, and then the next day, or I'll just make videos for those who can't show up. So yes, we're being recorded, but I don't want to have to do this over and over again with different groups because it gets old and it's long, you know, so it's a final exam. So, okay. Perform the indicated operation. So here sometimes students, they multiply a binomial and trinomial. I'm like, this is not multiplied. The operation here is subtract, yes? So I would, if I'm subtracting a polynomial, I would always put a 1 here and distribute that -1. So students like to take shortcuts and they want to immediately combine like terms, and I always say that is not safe, especially if this were a plus, it wouldn't be a big deal. The parentheses don't matter, but when it's a minus, the parentheses most certainly matter. So you have 6y plus 7. -1 times -6 is +6. -1 times -4 is positive. And negative times positive is negative, you see? So this is really a critical first step. Once you do that, now combine. So then you say, okay, what are like terms? We have a 6y squared first. Nothing's going to happen with this thing. But then we have a 6y plus a 4y. That's $6 plus $4 is $10. And then we have a 7 minus a 7, and those disappear. They cancel each other out, right? But they don't always, so don't assume anything. How we done? So that's all it is distribute the negative sign, combine like terms. And then yell at me if I'm going too fast. I didn't have to scroll by every problem. So we're almost done with the chapter 5 piece. Okay. Multiply binomial and a trinomial. So everything in this is, people say I want to FOIL that. Foiling is when you have 2 and 2. You know, that's then the first, the outer, the inner, and the last. We're doing the same thing, except you can't really call it FOIL because we don't just have 4 terms total. So we're going to multiply everything in the second one by everything in the first one. So we're going to distribute through. So usually I do the arrows and I say 2x times 5x squared is 10x cubed. Now here you just have to be careful with the exponents. 2x times 7x is 14x. 2x times -4 is -8x. And then I'm going to ask you to keep an eye on me, because when I do a lot of this basic math in my head, I do make mistakes. So if you see something wrong, please yell, do something. Don't just let me continue on and we're taping this whole thing, you know? Okay, so then we're going to distribute this thing through. And in the book, sometimes it says multiply vertically, or students really like to do things vertically. Like they're going to say 8 times 5x squared is 40x squared, and then they want to line it up or something. I have something wrong already. I found something wrong. You guys, you're supposed to stop me when I'm wrong. 2x times 5x squared, 10x cubed. 2x times 7x, 14x squared. Yes? Mm-hmm. Don't leave me hanging. Okay. I caught it myself, but you know, it's hard to cut because I'm talking, I'm moving stuff around. Anyway, 8 times 5x squared is 40x squared. So some people want to line this up with this x squared term. I don't do it that way. I just do horizontally, meaning now I'm going to take the 8 times 5x squared and I just hang it over here. So it's personal preference. There's nothing wrong if you like to stack them. 8 times 5x squared, 40x squared, 8 times 7x. 8 times 7 is what, 56? That's one of my weaknesses, that 56 and the 54, those two numbers. And then 8 times -4 is -32. Double check. Yes, okay, I see your heads nodding, we're okay. And then you combine like terms. So you only have one 10x cubed or 1x cubed type of term. Then you have $14 plus $40, or 14 apples, and 40 apples is 54 apples. Yes? So you're not changing the exponent. If you have an x cubed times x to the 4th, you do get x to the 7th, but that's when I'm multiplying, I add my exponents. Right? When I'm multiplying, I add them. But when I'm combining, I just say 14 apples and 40 apples is 54 apples. And then I borrow $8, or I have a -$8 in my checking account, and I deposit $56. How much do I have in my checking account? Definitely positive. Is it 48? Mm-hmm. Catch me if I'm wrong. And then the negative 32 is hanging there. I'm waiting for confirmation. Amber's making a serious face. That means I messed something up.
I thought it was, I think I just probably did my math wrong.
No, I probably did my math wrong. Hang on. It's a review for the final, you know, let's make sure it's right. Oh, it's 48. Or did I do something wrong with the others?
I thought it was the 42x. I had 42x plus 10x cubed plus 54x squared minus 32. But it was probably just my simple math I just did wrong. 56 minus 14, that's probably what I did wrong.
Well, it might have been where
56 minus 14, is that what you did?
Minus 8.
Oh, 8, okay. Nope, that
because
was on
those
me.
are the x terms. After I fixed my square on that x squared term, maybe because you see how I messed up earlier in the beginning and I accidentally didn't have that 2 there.
Okay.
And then you might have combined those 3 x terms, but then I fixed it. Yeah.
Okay. Mm-hmm.
Okay, so then this is a 4-term polynomial. Sometimes stuff cancels, you know, and sometimes you have a string of terms. Remember not to put them together. Those are not like terms. For them to be like, you have to have the same variable, same exponent. Okay, so we now have 6 people. Okay. Hang on. To move it. So I can't see all of you. It's a problem for me. There. Okay. So yell at me if somebody's chatting or something's happening. Okay, so now we're going to divide. And this actually ties into some of this stuff we did in chapter 10 and 11 with the division here. Okay, so if you had me in the beginning at chapter 5, we did the division by a monomial, and we said if you divide by a monomial, if it was a monomial, we said split them. That's the way we worked them in class. And if it was the denominator, you know, divide by, meaning the thing in the denominator. And if that thing was a binomial, we did, if you had me in class and or watched videos or whatever, we said do the long division, remember? So if you do long division when the denominator is a monomial, it may work, it may not work, because it depends on the exponent. This exponent's bigger than that one, so you're gonna have a problem. So if you're dividing by monomial, just split them. Please focus on that. Don't try to do long division. And long division, well, we just really want to use it when there's a binomial. So then we can say, okay, well, do I need to worry about that? Do I need to go back to my first test and practice that or whatever for this final? And I'm going to give you a little hint. Everything that's on this exam here, you definitely need to know. Yes? So just a minute, honey. It's already graham cracker duty. So anyway, you want to focus on what I'm focusing on here instead of worrying about all the things that might be on there that aren't on here. Yes? Especially with this condensed version thing. Okay, so we're going to finish this one and then we'll go on to the next one where I want you guys to maybe focus on what's going on before I start grabbing graham crackers. Okay, so I'm dividing by a monomial. So I'm going to say everything in the upstairs is divided by that thing in the downstairs. Now be careful, sometimes that thing in the downstairs is a negative. But in this case, it's just a 12x to the 6. 36x to the 6 over 12x to the 6. And then you simplify. This negative divided by positive is a negative. 16 over 12, and then I can do basic math and say 2 times 2 times 2 times 2, 2 times 2 times 3, cancel, cancel. Or you could just say, hey, they're both divisible by 4. That's the biggest thing, they're divisible by 4, and this is going to be a 4, and this is going to be a 3. You see? So up to you. Yes, do I need to show that again? Really basic stuff, or you plug it in your calculator and it'll shoot it out, but 16 12s. 2, 2, 2, 2, you know, and I don't want to do that all the time, but you know, this is it. 4 over 3, 2 times 2 is 4. So now it says your internet connection is unstable, so I hope it doesn't get too messy. Anyway, you can do this kind of process with anything you have, or you can do the shortcuts. Now, what about x to the 5th over x to the 6th? You know, you can do this and this. You don't want to do that every time. What if I have x to the 81st? So then you can cancel, 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 and then you say, what's left? And where is it? And that's the key. You see, because some people say, well, it's just x. It's not x. It's really 1 over x, because x is downstairs and it needs to stay there. The other thing you can do is x to the 5th over x to the 6th is x to the 5 minus 6. This is using that quotient rule that we learned. You know, when you're dividing, you can subtract them, but the upstairs one goes first. Well, that causes an x to the negative 1. And folks, we cannot put a negative exponent in a final answer. What is x to the negative 1? It's 1 over x, because we say, hey, that thing is upstairs. It has a bad attitude. We're going to put it in the basement. Remember, all that stuff that we've done is hopefully coming back as we review. So anyway, so this one here, you can just, or you can visualize them in your head, you know, how many are there? What cancels, and then I have an x left. Plus this one here, 36 over 12. You can break it down, or you can just say 12 goes into 36, what, how many times? 3. And x to the 6 over x to the 6, cancel, cancel. Or you can say x to the 6 minus 6 is x to the 0. Folks, x to the 0 is not x. X to the 0 is 1, because that was that rule. Anything to the 0 power is 1. So you can do this so many different ways. But if you have 6 upstairs and 6 downstairs, and you looked at it like this and you cancel them all, you still have none left over. How we done? Most fun thing you ever did on a Tuesday morning?
It's getting me out of work for an hour. So
there you go. And what a good excuse. So this should help you, you know, doing all this stuff. And then you should, if you're really comfortable, you know, whenever you feel like you want to take that final, it's not, I cannot make it available before Friday, because we're supposed to stick with finals week. So I used to do Monday. Well, that's not reasonable for people, you know, especially online, or people who work. I mean, you might work all weekend. You might need, or you might work on Monday through Wednesday, 36 hours total, you know, it's, you just don't know. So you guys do it when you want, but it opens Friday morning. And then you're free to go, whatever you want. But you only have one shot, so you really want to make sure you're prepared, and you want to make sure you have a distraction-free environment, etc.
I have a question on that one, though.
On the last one?
Yeah. How come you don't want to factor the numerator?
Oh, and I can, but we didn't know how to factor at the time. You see?
Okay.
So
Okay.
hang on, I'll bring it back. You know what? That's exactly, that's a perfect question. It's just that you know a lot of stuff now that you didn't know back when.
Right.
Think about this. This is chapter 5, and you didn't have a clue how to factor. You learned how to factor in chapter 6. Great question. I like this. See, this is what critical thinking is, when you start thinking, oh, what else do I do? So what did these two have in common? I want to work it now. I have to. 16 and 36, what's in both of them?
Yeah, 4.
4. And they both have an x to the 5th.
Right.
You see? But if you do it this way, you may have to add steps later. You know, I don't know yet how this is going to turn out. That one times that one is that one, plus, oops, now you have the minus. Negative times negative is positive, and then you have a 9. X because x times x to the 5th is x to the 6th, you see? And then downstairs you'd have a 12x to the 6th, so you could say 4 times 3x to the 6. But you see how this gets a little more convoluted when you do it this way. And then you would cancel these two, and you would cancel this over x, but then you still have to split them up and divide each one. So in this case, factor and cancel is not the greatest idea, honestly.
Okay.
You see, it just gets more convoluted. So what I'd say is if you have, especially, okay, so the final starts, it's in about this order. So it doesn't start with graphing. You know how in the semester we did chapter 3, 4, and 9 because those were all graphing, and then we turned around and we did polynomials and we factored, and then we did the crazy imaginary and radical stuff. So, but that was a good question because this is really the problem. We have a lot of options and you have tools. And there's lots of ways to do it, and they're not wrong, but different. Okay, so now we're going to factor. So this is both math 110 and 112. There's really not a lot of difference between the two courses. I'm trying to get rid of that 6, but I can't. So it says factor out the GCF. So this is 5A. So it's telling you to factor out the GCF. Really what I'd like to just say always is just factor. I say factor, you say greatest common factor always. And then you say, well, what do these things have in common? So all you're going to do is factor 35, 25, and 40. There's a 5. Is there more than a 5? Is there 15 in all of those? No, you see? And then you say, what else is in them all? They all have an X piece, yes? So I always say, pull it forward and then open a parentheses, and then this times this has to be that, this times this has to be that, and this times this has to be that. So you're doing chapter 5 in reverse. So 5 times what is 35? 7. X times what is x to the 6? X to the 5th. 5 times what is 25? So we have a negative 5, and x times x is x squared. How we done? Stuff should be super comfortable, or at least like, oh, I've seen that before. I need to review a little bit. 5 times what is 40? 8. 5x times 8 is 40x true. And that's the end of the story. And folks, don't try to factor this trinomial. So later it could be, so it'll say factor. It'll just say factor. So then the first thing you do is you pull the greatest common factor forward, and then you say, am I done? And you may try to factor this trinomial. But if all it says is factor out the GCF, please don't make it worse. And it's going to be 2 points. I think you can see, if you can see while you're working how many points it's worth, then you kind of know, oh gosh, if it's only worth 2 points, I probably shouldn't do a ton of work. Does that make sense?
Mm-hmm.
And then we have, then I wanted another one just in case. So this is another example. What do they have in common? There's a 2 in here, a 2 and a 5, and there's 2s in here and 4s. So we pull a 2x open, 2x times what is 10x to the 4th. So hopefully this stuff is easy for you now because you've done so much chapter 6 and beyond. 2x times what is negative 4x squared. 2x times what is 16x. And then you can always double check by distributing, and you go right back where you started. All is well? Okay, I see nodding. Okay, I don't know if I can see everybody. Come here thing, it won't let me stretch you all up some. I have the mouse on, I still can't stretch it. Why is that? Technical difficulties. Did Amanda leave? Is she still here? Everybody's here still? We have 7? Okay.
No, I'm here. My
Okay.
internet, if you don't see me, it's
Okay.
kicking me on. And
No,
off.
it's okay. Usually I can at least see your name,
Yeah.
you know.
No,
and
I'm here.
I can't get you guys stretched to where I can see your faces or see that you're here. It's fine. I just want to make sure because we're going to cover your problem later. I put it on here and
Okay.
you and I will definitely cover it. So I just want some kind of a system since we're doing this on recording. Okay, so,
Yep, no, I'm here.
okay. So it says factor the 4-term polynomial by grouping. And again, I do not like it when it tells me what to do. I just want it to tell me to factor. Because when it says factor, my brain, the first thing I do is there a GCF? Because if it could say this, there could be a GCF and you won't think about it because it says my internet connection is unstable. Oh. You may be misled a little bit. So really all it should say is factor, and then I want you to always go through these steps. Step 1, GCF is their greatest common factor. You still want to do that because you might miss something. But then you look at this and say there's 3 and 3, and there's a 3 in here, but there's no 3 in here. There's no 2 in the 9, so there's no GCF between all of them. Then you say, in this case, no. Then you say, how many terms? So this is where... Then you ask how many terms. If it's a binomial, you know, this is that factoring summary that I preach in the actual classroom. But if it's a binomial, you ask, is it a difference of squares? You know, this is all in your guys' notes somewhere. And if it's a difference of squares, you say a plus b times a minus b, because that's how you factor those. But if it's a trinomial, then you ask, is it a simple one, which means it starts with a 1, then you just open, close, x, x. If it's a trinomial, and it's really, if it's something that starts with a 2x squared and there isn't the greatest common factor or something, you know, or if it's, let's call it ax squared, where a is not 1, then you go over the top. We're going to do all of this, but I only want to go over this summary one time, you know. But if it's a, this is here, if it starts with a 1, you simply open, close, and you do your thing, and you need a product that's C and a sum that's B. If it's a trinomial like this, where it starts with a something other than 1, then you go over the top, and what you'll do is you'll rewrite this one, but then you split the middle term into 2, and then you factor by grouping, because you're going to have 4 terms. You see? So that's the if and if and if. And if it's a 4-term polynomial, whoops, then you factor by grouping. Yes? That's all, that's really what you need. And then step 3 is there anything else you can do? So sometimes there's repeated factoring going on, so you can continue factoring things. So, you know, then step 3 is, can you factor anything else? Meaning, is it completely factored when you get done? So that's it for the steps, you know. But so I'm going to look at this and say, I tried to pull a GCF, there wasn't one, and I'm going to double bubble because it's a factor by grouping. We call that double bubble in the classroom. It's a little silly, but it really helps. So we have a bubble and a bubble, and you make sure that that sign here is in that second bubble. And then, okay. Then you say, what, the first group, what do they have in common? You see, you want to pull a GCF from the first group. So they both have a 3, but that's not good enough. You want to pull the biggest, the greatest common factor, and they both have a 9, and they both have an x. You see it? So you say, oh, they both have 9x. Then you open a parentheses and say 9x times what is 9x squared? X. Then you say 9x times what is negative 18xy? Negative 2y. You see? And you can check all this by distributing back through. This times this is that true. This times this is that true. Then you bring this sign down. Students don't bring the sign down. They immediately open a parentheses and I'm like, that's not correct. Sorry, he's watching Toy Story, so now he has his Buzz Lightyear out.
Better than Aladdin, right?
I guess, but I don't know. Those toys are loud. Okay, so you bring that negative down no matter what, and then you say, what do these two have in common? They both have a 2. Then you open, and you say negative 2 times what? Is negative 2x. Calvin, bitte. Hey. I let him be really loud, but he knows when I'm on this, he needs to be a little bit considerate. He's only 3, so that's hard. Negative 2 times x is negative 2x. Negative 2 times what is positive 4y, see? And this is where students struggle a lot. So if you bring that sign down, you won't have a problem because negative times negative is that positive, you see? So negative times negative is positive, 2 times 2 is 4, and the y needs to be here. So we have separate steps for, well, I'll explain them again. Now, I'm going to look at originally, I had how many terms? 4, you see? 1, 2, 3, 4. Terms are separated by plus, minus, equal signs. And then you say, okay, now how many terms do you have? Technically, you have one big term and one big term. And your goal, completely factored, means one term. Everything's multiplication. You see, this is addition and subtraction. Factoring means create multiplication. So then maybe if you understand that a little deeper, this will make your life easier later to recognize, when am I done? Oh, what's going on, you know? Okay, so these two terms, they have something in common? And I don't always like to underline this, so it's very obvious. You see how these two terms have a factor in common. It happens to be a binomial. And what you do with that is you pull it forward, and then you put the leftovers, is what I call them. None of this is technical terms, you know, but you put the leftovers in here. So steps for factoring, you see here it just says, this is steps for how to factor, but then the individual method has its own steps. So this one here is what we dealt with. If it's for term, we group, meaning we double bubble. So, you know, this has its own steps. First, you double bubble. Or call it something else. Some people hate that. They think it's cheesy. So I say, okay, then do something like this if it makes you happier. I don't care, really. It doesn't matter to me. And then second, from each group you pull, you know? So if you need this in your notes, you don't have to write everything down. I just want to make sure it's fully understood now. Pull GCF from each group. That's what you did right there, you see? Then you pull the greatest common binomial factor, which is that thing underlined. And then leftovers in second set. How's that? Crystal clear? Super comfortable for the final? Yeah? Okay. Okay. All right. So this time it says factor completely. You should always factor completely. Why is it saying that this time? Because the thing is kind of hinting at you that you need to pull a GCF first. I wouldn't worry about it. If you had a t squared here, you might accidentally do an over the top. I don't want you to do an over the top if it's not necessary. So step one, GCF. And I will keep writing that one down because that's that thing I yell about in class all the time. If you pull this first, your life will be easier. So you pull the GCF, well, they all have a 5. Oh, great, it's gonna be a simple trinomial later, meaning makes my life easy. The greatest t's they have is 3. All of them include a t cubed. Open. 5t cubed times what is 5t to the 5th? T squared. 5t cubed times what is negative 49t to the 4th? Negative 9t. Yes, t cubed times t is t to the 4th. And 5t cubed times what is 100t cubed plus 20. Close. Yes? So you pulled your GCF, and then you say, now what is it? What is left? Can I factor it? This is now a trinomial. Do you want to do? Some people split the middle. I'm like, you can. It's not illegal, but it's why would you do such a thing? Keep it simple. Keep it simple if you can, because your life is easier that way, and easier in this case is better. So you have one that starts with a t squared, meaning the leading coefficient is 1. So you simply open, close, open, close. Don't forget to bring down your 5t cubed because that's part of your final answer. And then you say, oh, this is a t and this is a t. And then on the test, you know, you may want to double check your stuff. Also ask me to look over your exams. I don't understand why more people don't ask me. Some of you would do this perfectly and you accidentally have a T and an X. You know, you get most of your points because you know what you're doing, but you accidentally wrote an X. This is so crazy that people don't ask me to check their work. Arg. Anyway, so what is my product? 20. What is my sum? Negative 9, right? This is always, I put the product here, I put the sum here, and then I fiddle around here until I find two numbers that give me 20 and a 9. So 1 times 20, never gonna happen, trash. 2 times 10, not gonna happen, trash. How about a 4 and a 5? And then for you to get a negative 9, you have to have 2 negatives. So you probably saw this immediately. I showed the whole process in case you don't. Negative 4 times negative 5 is positive 20. Borrow 4, borrow 5, 9, true. And then you say, am I done? You see? So now here, students have worked so hard all semester and they learned so many things. And then here, all of a sudden, they tell me T is 4 and T is 5 because they want to keep going, you know, like they're like, this isn't dead yet. I got to beat it up some more. And I'm like, why would you do this? When would you do this? And why does it not work here?
That for when I equals 0.
Exactly, perfect. So if you're solving, you see what I'm saying? Meaning it has to be an equation. This is not an equation. This is simply a trinomial. You see what I'm saying? This is not an equation. So don't do stuff that you're not supposed to be doing. So, but I want to bring it up, you know, because that way it doesn't happen. Yes, if all you ask to do is factor, then all you do is factor. Okay, so how we doing? Feeling pretty good? Ideally, you look at this and work with me and then say, you know what, this came back right away. I didn't need much anything else and I'm not going to look it over again. Some people, I don't want to say overstudy. Some people don't study enough. A lot of people don't study enough. Like, so they don't do anything all semester. And then the night before the final exam, they cram all night. And then they say, well, I crammed all night and I didn't get an A. Like, that's because you didn't practice all semester. But if you've been working all semester, you know, just have to have some confidence that, yes, I've done this before. I can do this again. And don't cram the night before because you need your rest. Your body needs rest. Oh no, she told me sleep all night and now I didn't study. That doesn't go either, you know. Anyway, so this is a trinomial. I say factor, you say GCF. Yes? Is there one between 7, 5, and 34? Not going to happen. Then you say, no, not in this case. Then you say, what is it? It's a trinomial. Is it simple? Meaning, did it start with x squared? No. Then you say, oh man, it's a trinomial that goes over the top. Yes? So this is an over the top. So you go over the top, Some of you, especially if you're an online student, you might have just gone straight to trial and error. Some people do that, guess and check, where they play around here until they stumble upon stuff that works. If they foil it in their head, most of us can't do that. So we're going to go the route that we're going to factor by grouping. That's the method. The book shows both methods. It's just that this trial and error thing works for very few people. In this specific case, this is a small number and this is a small number. It's not hard. But what if this is a 12 and this is a 36, or a 12 and a 35 or something, and then you have a lot of options, so you have to be careful. So this always works no matter what. So you're going to go over the top. You're going to rewrite this one. We're going to rewrite that one. And we're going to split the middle up. And we're going to use what we find here. When we went over the top, we had a product of negative 35, and we have a sum of negative 34. You see? So then people play with this. 35 is 5 times 7, but that's not going to help, because 5 and 7, no matter what the signs are, it's never going to give you 34 when you add them together. So what do you use? You have no other choice but 1 and 35. You see it? Or 35 and 1. And 1 has to be negative to make that negative. So in this case, to get that negative 34, do you agree that this has to be negative? So 1 times negative 35 is negative 35 true. 1 minus 35 is negative 34 true. And then you say, okay, where do I put each one? And I'll tell you, if you make this one here, you want for this one to have something in common with that 5. It'll make your life a little easier. It really works either way. It doesn't matter. But we're going to split the middle term. And then some people just say it's plus 1 minus 35. I said, no, it's plus 1x minus 35x. Because when you combine these two, you have to have an x term. Yes? Now you have 4 terms. What do you do when you have 4 terms? You double bubble. And always check this. Plus 1x minus 35x is negative 34x. True, you didn't change anything. You just split the middle term. And now you do factor by grouping. First group, what do they have in common? There's an x. X times 7x, 7x squared. X times what is x? 1. Then you bring down the negative sign like I asked you to, because it's critical. And then you say, what do these have in common? I see a 5. 5 times what is 35x? You see, and you check your signs again too. Negative 5 times 7x, negative 35x, true. And then here people put a minus. Negative times what is negative? You see? Negative 5 times what is negative 5? It has to be a positive one. Now you have 2 terms. They have this binomial factor in common, and you pull it forward. And you put your leftovers in the second set. And like I said, in this specific example, you could have easily done guess and check or trial and error method, not a problem. But when the numbers get bigger, it's a lot better to do this method, or it's better for most. I'm not saying it's always better. So I think I have some chats. Maybe I should read my chats. Let me pull up the next one, or unless maybe there was a question. Oh, thanks, Adam. Oh, rest is for the birds. Yeah, I know. We can die when we can sleep when we're dead. Is what I usually say. It sounds terrible. Okay, so I'm going to clear the screen. Are we okay? Like, okay, yell at me. I'm going to move on. Why do I give you all these formulas? It's so funny because I give people formulas now. We used to have to memorize them all. And then now still people struggle with it. I'm like, okay, so why am I giving you formulas so that hopefully you can use them and apply them? But if you don't know what they mean, you can do it without. You just have to know well, this is the one formula you have to know. This is the difference of squares. You know, this is a difference. And it's something squared and something squared. Now, here's the main mistake people make. They immediately take this and they say it's a difference of squares. So if you were in my class, I would yell again really loudly and I say factor, you say greatest common factor always. So you would not say, oh, this is a binomial, is it a difference of squares? You don't say that until after you pull the GCF. So you see what I'm saying? This is going to change everything. So do they have something in common? Yes, they both have a 9. What else do they have in common? An x squared. You pull that forward, you open, and then you say 9x squared times what is 9x to the 4th? X squared. And then you say 9x squared times what is negative 81x squared. Yes? So you still need to do this. And I'll show you in a minute why you really need to do this. I do like to show it again. You know, and you could say, well, this is going to take forever if she goes into such detail, but I really want people to kind of get it, you know, not just, oh, I'm memorizing this stuff for the final. Okay, so this comes down, and then this thing you should ask, am I done? Well, is it a difference? Yes, it's a minus. It wouldn't work if it's a plus. This is a difference, yes. Something squared, yes, that something is x. Something squared, yes, that something is 3. And then you say, oh, a squared minus b squared is a plus b and a minus b. And now this is completely factored. Now, if you had another squared here somewhere, you would want to be careful and say, maybe I can do more. So let me show you the other. So what if you're having a moment, you know, and you forget this thing? And you say, well, is this a difference of squares? I don't want you to do it this way. I'm not saying you can't because it's actually fixable, but students never do. And they'll say, oh, a would be 3x squared.
Ms. Gentry.
Yes. Yes.
Ms. Gentry. Tiffany's wondering, she says she has to get back to work at 10, and where's
Okay.
the recording going to be posted? I told her it should be in the module, if that's correct.
Yes, I'm going to put it into the final exam module. I already have some stuff posted there, the videos that I couldn't decide if I wanted to put them with exam 3 or not. One of them is over chapter 9 that's specific to the final exam. So I have a thing in there with video links. I will put it there. Yes?
Thank you.
Okay, no problem. And then you can just forward and shut me up for the rest of it, but forward it to here where you find it interesting. Okay, so b is 9x, right? Because what if this something squared, and you never worry about signs when you're dealing with a formula like this. So then you say, okay, it's a plus b times a minus b. But then the problem is, what is the problem now? You know, it says completely, it always means completely. Is this factored completely? Look at these two terms, they have something in common. What is in common between these terms? They both have a 3x. You see, this is why I would never want you to do it this way, and there's no sign here now. What do these have in common? A 3x. You see what I'm saying? And now this piece and that piece makes this piece. Not a good idea. I always say, pull that GCF first before you fiddle with anything else. Don't even worry about what it is. If it says factor, you would first immediately pull the GCF. Okay. Woo. So see, now this was chapter 6. We're done with chapter 6, and this is now chapter 7. It says my internet's connection is unstable, but you see now all we have is 7.1 and 7.2 because for this specific semester we killed the rest of chapter 7. So this shouldn't be terribly long, but I'm going to stop the recording and I'm going to start a new one. Is that okay? Let's take a 5-minute break. And I know, Tiffany, you got to go back to work, but that way at least you only have to worry about that next recording. And I'll put them all in there. I have to upload them to YouTube. But I'm going to stop this recording